Multitech Engineering College. For me, the event topic is data exchange formats, IGS and STEC. So what is data? Why data exchange formats appear for computer design? So the data is a signal, is a system. So the data you have to represent with respect to the known format. And why do you need data exchange format? So that's happening between two dissimilar systems. So we should know what is system. So the system is nothing but capable of a module that can be designed or assigned to perform some task. So the task may be defined the collection of data. So the data may be represented in terms of many formats, but in generally they are representing in terms of binary formats. So the binary format that is nothing but zeros and ones that will be easily processed with the help of computer. So we need a computer to perform to execute any systems. So why do you need the exchange format? So the exchange format is also called as data translation. So why do you need a data translation between two dissimilar systems? So what about the system? You know, system is nothing but capable of components which can be used to assign to perform some task. So what is meant by similar system? A similar system is nothing but the component which is very common to two different process or two different domain or two different modules to process the same modules, to process the same task. And what about, for example, you take the language Tamil. So Tamil பத்தி நீங்க தமிழ் தெரிஞ்சவங்க பேசுறீங்க அப்படின்னா ஈஸியா அண்டர்ஸ்டாண்ட் ஆகும். பட் தமிழ் வந்து ஒரு ஹிந்திக்காரர்கிட்ட பேசுறீங்க அப்படின்னா so there will be some difficulties. So you need a translator to translate Tamil into Hindi. So the same concept is available to our computer aided design. So we can draw a design with the help of paper. How can you bring it into a computer to process it or to execute it? So that's why they are making the communication between two similar systems, two dissimilar systems. So to make communication between two dissimilar systems, we need an effective and efficient module to compute it. So that's why we need a data exchange format. So here in CAD, computer aided design, especially for mechanical engineers, that will be implemented with the help of two systems, IGS and STEC. Okay. So for CAD and CAM design engineers, we can use three set of softwares. So software used for implementing the whatever we design. So for example, if you want to design a rectangle, so we have to specify the what is the length and what is the breadth, and we can bring out the formula A into B. So the area of rectangle is equal to A into B. The same concept how can you bring into a computer, and what kind, for example, we can use the following systems. For CAD and CAM, we can use SolidWorks, OE, CA, TIA, Unigraphs, IDEAS, CAD, and AutoCAD. And one more system, if you want to program and to bring out the graphical expression, graphical module, we can use a software Java 3D, C, C++, OpenGL, DirectX, VRML, FTP, Delineate, and Web browsers. And if you want to solve the symbolic expressions, we can use the symbolic equation solver. For example, you take MATLAB, Maple, MathCAD, and Mathematica. So by using these things, not only for mechanical engineers, we use these things for our any domain. You take electrical domain or you take electronics domain, whatever it is, if you are bringing concept in terms of paperwork, and you can bring it into computer with the help of these softwares. So, what is the main disciplines for CAD and CAM? So, the CAD can be used for, we can bring the geometrical modeling, the computer graphics, and the design part. And using the CAM design, we can bring CAD, automation, and manufacturing. So, if you combine both CAD and CAM, we can bring out a lot of things. So, one, CAD design, CAD, computer aided design, the design part, and another one is for the geometrical modeling, and another one computer graphics and manufacturing and automation. So by using CAD and CAM, you are combining both, you can bring a product up to manufacturing level. So this is very important for CAD and CAM. And what are the CAD file formats? What are the CAD file formats? So if you want to store something in terms of binary formats or ASCII code, or you take some of the formats, so how do you store it? So the storing value is very important. So for example, if you are capturing this row, so it is not possible to store it. So we need a compression. So if you want to compress that, we need an exchange format. That is nothing but we have to convert it into binary format. So first point, what is the first point? Every CAD package stores information internally in a format that is best for suitable module, suitable package. Whenever the user is done, this information is written to the files on the order or drive. So the information. So information is very important technical term which is very close to information coding theory, information theory. What about information? So information is nothing but the data collection of systems, data collection. So that will be represented in terms of bits per second. So how many message or how many information is collecting per second? How many? For example, you take my speech. I'm telling in different terms, different symbols. For example, you take SYMBOLS. So symbols. So how many words coming from me per second? That is also information. Okay. And using this format, we can perform specific program and specific module or specific task. And for modern engineering application, it is necessary to be able to transfer CAD models between two dissimilar computer programs. I already told you what is system and what is similar system and what is meant by two dissimilar systems. So here we are making the communication between two different models. So according to our mechanical engineers, so here we are drawing in terms of paperwork. How do you bring it into the computer? So paperwork is one module and bringing into computer is another one. So how do you make communication between paperwork and computer? So that to make proper communication, to make effective communication, we need data formats. And standard file formats. So you can bring any file formats, you can bring out whatever it is. For example, you take in our world, we are speaking in nearly 3,000 languages. Okay, so if you want to understand the one language from the another one, so you need a proper translator. So it's not important, it is not possible to make a translator to all kind of languages. So we need to bring out the standard formats. So standard file formats to transfer data from one dissimilar system to another dissimilar systems. So standard file formats are best method for storing and transferring CAD geometries and other information between two dissimilar programs. And the last one, files are mainly stored in on this as ASCII codes or binary. I already told you why binary code is important and ASCII code is important. So that is the language to understand the computer. So computer will understand in terms of binary, whatever you are giving the input to the computer. So So that will be converted into zeros and ones, so the computer will understand. And what is style format? So the basic structure of programs using standard file is shown in figure. You take a program A, and that is designed with the help of CAD. You are storing in terms of CAD, and another one is called the program B. So using the standard CAD file format, you are exchanging the data between program 1 and program 2. What about program 1 and what about program 2? That is designed with the help of designers. So according to the specification, the designer will make the program. So you can use Java, you can use C, C++, whatever you like, whatever you can with the high-level language, you can program it, and by using some standard formats, you can exchange it. So here we are using the standard files for IGS and STEM. And what about the typical application of CAD and CAM, or you take the prototype model? So using the CAD systems, you are giving the data to the data transfer, and using the same another one smart CAM system, you are getting the data. I mean, you are extracting the data from there and giving to the another one. Using the CAM system, again you are giving to another one that will be converted into codes, some different codes. And based on that, again you are collecting back using some machines, again given to these other systems. So you can easily understand based on this kind of typical application. So what's happening on this diagram? Some data transfer is happening. So the data, you take the first one, some data is transferred to this system. Again, you are getting or you are extracting some data from this part to another one. And again, you are extracting some information from there to code generation. From the code generation, you are getting some other data and given to the another one. So the data is exchanging or data translation is happening between two dissimilar systems. For example, you take a CAD system, it is not similar to this, and you take this system, it is compared to the another one, it is not similar to that. So you are making the communication between two dissimilar systems. I think you are understanding the meaning for this. So the data transfer is a prototype drawn using CAD and transferred to the smart CAD via CAD, so that it can be generated the NC code to manufacture the part. Finally, it is transferred to the milling machine using G code. Okay, so what about the milling machine? If you want to operate your milling machines, so you need on and off. So the on and off, you need a proper signal to the milling machine that is given through the CAD and CAM. So proper instructions you need to execute to compute the value of milling machine. So you can assign a different work to the milling machine. So based on your instruction, so that is nothing but instruction information that is executed with the help of high-level language, and moreover that file is transferred to operate the milling machine. So the file format. So you need a standard file format to execute to get the effective values of your systems. So why you need standard files? So universally readable, allowing easy data transfer. So the data transfer is very important. So how do you compute the data transfer rate? So data transfer rate is very important. So for example, I'll tell you one more. Everybody is using the mobile phone. So if you want to transfer the photo from one cell phone to another cell phone, so within a second the photo will be transferred from one cell phone to another cell phone. So if you want to transfer photo, or you take mail, or you take some other text, is transferring from one computer to another computer, or one mobile phone to another mobile, you have to define the standard. So the standard one is nothing but you have to use easy, and moreover you need a speed. What about the data rate? You have to specify. So you have to install the rate of the system. Data rate is very important. So easy data transfer, and moreover another one point is dependable than proprietary formats. That's meaning you have to bring out the better throughput. So what about the throughput is nothing but we can say in terms of outputs, how much output you are getting from that. So what about the graphic formats? So this is somewhat related to the CAD and CAM. So if you want to store your data in terms of your system, with respect to your system, we need standard formats. So what about first format? Graphics interface interchange format. So using it we can bring out a graphical one. So if you want to draw your rectangular, you take a scalar or you complicated graph. So using this we can bring out. And what about another one? JPEG, joint holographic expert group. And what about this? Using this you can bring out the compressed format. So I already told you, if you want to store a picture based on the digital camera, so what's happening, the real one and the digital camera, the compressed one is stored in the digital format, so stored in the digital system. So you cannot bring out all the data into that. So you can compress the data and you can use, you can store into the digital format in the digital systems. So based on this format you can bring out it. So based on this file you can store it. And what about another one? MPEG, a motion pictures expert group. So this is for the specially designed for the motion pictures. If you want to store motion pictures with respect to digital system, we can use this. So which is also available in compressed animation. So apart from this, you can bring out two more graphic formats, HP, GL and PostGraph. So these two will be useful for our CAD and CAM design engineers. And what about CAD formats? What about CAD formats? So you can get a lot of formats that is designed with respect to the different systems or different organizations. So what about the first one? CG, M, and another one CIF, DMC, DFX, IGS. And so this topic is going to discuss IGS. What about IGS? Initial graphics, exchange specification. And another one EAF, IASF, set, step, and PDS. So step and PDS, that is nothing but a standard for the exchange of product model or data. And VDFS, VDAIS, and IDS Universal File. So based on these CAD formats, you can bring out a lot of things. But here we are going to use two formats, IGS and the other one is called as step. And what about the standard format? So how do you define the standard formats for the CAD and CAM systems? So you take any device that should be independent format is based on the public standards that are controlled by non-commercial bodies. So this is very important. So you cannot control that formats. So you have to operate independently. You can download it. Is available from the net. You can download it and you can install with the help of your system, with the help of some formats and storing on your systems, and that should be operated independently. You should not depend on some other systems. So you have to operate independently from the anywhere. So for example, you take STP, standard exchange for product data, and another one set, standard exchange for data transfer, PDS, product to data exchange specification, and IGS, initial graphic exchange specifications. So these are the standard formats which are used in industrial side, especially for the mechanical engineers. And what about data transfer? I already told you the meaning for data transfer. Data translation is happening between two dissimilar systems. So you have to make the communication between two dissimilar systems. So data translation you take the representation that is called arrow mark, that is not depending on systems, is independent. Okay, so it is not necessary a common file to transfer. So Q data, you can easily order it with the help of proper communication, get the data and communicate it. But you take indirect translator, you need a dependent device. So you need a common mode, you need a common task. So you have to get a permission from there. So after getting the permission from there, you can translate the data. So what is the difference between both direct translator and indirect translator? So for direct translator, it is an independent device, whereas you take indirect translator, you need a dependent device. So you need a neutral file. So from the neutral file, you have to get the data. For example, you take system 1. System 1 is directly connected to the system 3, so it is not necessary to ask permission from a neutral. Whereas you take this indirect translator, so if you want to make communication between system 1 and system 3, you have to go through neutral file. So that is the difference. So you getting an idea about this? No?
So which one we are using in this? Which one we are using?
This one. Direct word. Indirect translate. So there is a hierarchy. So manager and assistant manager. So you have to ask another one employees and another one another stage. So to execute everything, you need a common boss. So you have to get the data from there. So that is better. Whereas you take your first one direct translator, you cannot get effective values. Execution is a problem. But whereas you take this, you can easily operate it. So if the system 1 is absent, you can get a trouble from the direct translator. But whereas you take your neutral file, so you can get the data, what happened, what's happening, what is the plan, you can get them from the second one. So indirect translator is better. So I am going to over topic, what does design to mean? IGS, Initial Graphic Exchange Specification. What is IGS? How do you define the term IGS, Initial Graphic Exchange Specification? And second point, how IGS can be used to make data translation between two similar systems? And what are the classifications of IGS that is classified with respect to three main categories? One, geometric and annotations and structure. Before going to define these things, you should know what is entities. So entities is nothing but the collection of data. See, for example, if you want to find out the area of a rectangle, so you have to define the entities. What about the length, small a, and what about breadth, small b, and what about area a? You are representing three terms, three letters, capital A, small a, and small b. And how do you find out the area of your rectangle? By using the formula length and breadth. So that is nothing but data. That is your data entries is called entities. So entities is nothing but is the collection of data, is specified the data in terms of some variables to execute or to compute the value of some task. So what about the task for us here? How do you find out the area of your rectangle? How do you find out the area of your cone? How do you find out the area of your sphere, for example? Okay, so if you want to find out the area of your cube or non-unshaped one, you have to bring out some methodology to define different variables to bring out the value of the area of it. Not only area of that, so you can bring out a lot of designs for your mechanical engineers. So based on that, you can bring out the entities. So entities simplest is the collection of data. So why collection of data is required? To execute some systems. So to execute a system, you need effective variables. efficient variables structure. So unnecessary variables specify பண்ணக்கூடாது. If you are specifying unnecessary variables on your system, you cannot get the proper outputs. So you will get errors. So error is not easy to eliminate. So that you need a proper variable assignment. And another question in the structure entities. And how you execute these things, we need a file structure and a file format to execute it. So what about IGS? IGS is nothing but expanded with respect to initial graphic exchange format, specification. It is the first standard exchange format developed to address the concept of communicating between two dissimilar systems. And what about IGS? So IGS has three type of data types. First one geometric, and another one is called annotation, and the third one is called structure. So the latter two are non-geometric data type. Geometric entities define a product shape and includes curves. So first one, what about first one geometric, and another two annotation and another known structures. So that is not necessary to define the geometric. So based on the structures you can implement. So if you want to implement these things, what about you want to define the entities for geometric works? What about the geometric geometry? So for example, you take entity descriptions, circular arc, curve, conic plane, line, spiral curve, point. So if you want to execute these things, you have to give the entity numbers. If you are giving the entity numbers, the system will identify them. Yes, you are giving, for example, you take 150 is given, you are that is nothing but you are giving the black entity to us. So the system will understand when you are giving this kind of data entity number. For example, you are giving the 186 to the system. The system will understand you are giving the LS. So based on this entity number, entity data, your IGS file will understand, yes, you are feeding this data to us to execute this. So we understand from it, then implement it to bring out the output list. And another one, what about IGS annotation entities? So it is not a geometric one, it is a non-geometric one. So you are defining the different identities to understand the different entity descriptions. So entity number, if you are feeding a 202, your system will understand the angular dimensions you are feeding. So what about angular dimensions? That is given by the design engineers. So how much data, how much theta values are here. So whatever you designing, you can define it. So for example, you are giving 230. So you are giving the sectional area of your cone, or sectional area of your cube, or you are giving the sectional area of your solids, some of the solids. So then system will understand based on the variables, system will understand, and that will be executed to bring out the proper output. And what about the structure entities? The same thing. So entities classified into two types, entity file and entity descriptions. And another one we not do. What about first case? You are giving in terms of 1 series. And what about the second case? You are giving in terms of 2 series. And what about your third case? You are giving in terms of 3 series and 4 series to understand the. For some difference you have to make, but to understand the systems. So what about the structure entities? So I think you know the meaning for structure entities. So structure and will get correct. And what about file formats for IGS, file structures? So everything will be executed with the help of combined compressed ASCII format. So ASCII format is nothing but you are expressing in terms of zeros and ones. Okay. So what about your first part terminal, parameter data section, directory entity section, global section, start section, and flag sections. So it is nothing but some hierarchy you are assigning to get the data. So some assignment is given to the systems file formats. So based on the file format, you can bring out the output to execute the output to get the proper task. And what about another one, STEP, standard for exchange of product data. And based on this topic, we are getting few questions. What is STEP? What is the difference between IGS and STEP? How do you explain the architecture of STEP? And what is the implement of STEP architecture? So nowadays, CAD engineers preparing this format. So what is STEP? So this is the advantages of STEP. This is the ISO standard one, which was designed ANSI standard. So ANSI C language. So C language is common domain for everybody. So you can easily understand, you can easily learn it. So after getting the information from the C language, you can bring out this format and go over the history of that. And what is this? The difference between two platforms, two formats. What about IGS and what about STEP? So IGS is what about STEP? STEP is nothing but your indirect translator, and what about IGS is nothing but direct translator. I think you know the difference between both, direct translator and indirect translator. So which is the best? Indirect translator is the best. You are bringing a neutral file and you are exchanging the data between two systems, system 1 and system 2. So that is the main one. And another one is called application layer. So that's very important one. So it is certain in terms of application units. So you can easily attach the application layer to the STEP. That's not happening in IGS. So IGS file you cannot bring out the application units. So what about application units? So based on the customer would sir இது எனக்கு பண்ணி கொடுக்கணும் அப்படின்னா அந்த விஷயத்தை ஈஸியாக பண்ண முடியும். பட் இந்த இடத்துல உங்களால் பண்ண முடியாது. ஸோ பண்ண முடியாதுன்னா அர்த்தம் you need some modification of the IGS. But instead you can easily bring out, so based on that product data. So what about product data? Based on the data that will be collected from the customer side, customer என்ன சொல்றாரோ அதுக்கு ஏற்ற மாதிரி என்ன பண்ணலாம், நீங்க இதை சேஞ்ச் பண்ண முடியும். So that is the major advantages of your STEP. Very clear? And what about another one? What is STEP? So STEP can be used to easily data change பண்ணலாம்னு சொல்றாங்க. And what about the data? That's very important one for us. What is the size of the data? What is the size of the data? Nowadays வெளியில பார்த்தீங்கன்னா ஒரு இம்பார்ட்டண்டான ஒரு ஹாட்டான டாபிக் போயிட்டு big data. What about big data? I'll tell you, for example, you take stock market. So stock market participate பண்ற கம்பெனிஸ் எத்தனை பேர் இருக்காங்க அப்படின்னு பார்த்தீங்கன்னா கிட்டத்தட்ட ஒரு 200 கம்பெனிஸ் இருக்குன்னு வச்சுக்கோங்களா. ஸோ 200 கம்பெனிஸ் பார்த்தீங்கன்னா அவங்க ஒரு 5 மினிட்ஸ்க்குள்ளே என்னென்ன நடக்குது, அடுத்த 5 மினிட்ஸ்க்குள்ளே என்னென்ன நடக்குது, அடுத்த 5 மினிட்ஸ்க்குள்ளே என்னென்ன நடக்குது. ஸோ பர் டே அவங்களுடைய அப் அண்ட் டவுன் பார்த்தீங்கன்னா நம்ம we are getting in terms of graph that will be drawn based on the data feedback fed to the system. இந்த டேட்டாவை எடுத்துக்கிட்டு அதெல்லாம் கரெக்டாக டேட்டாவை பார்த்தீங்கன்னா ரா டேட்டாவை எடுத்துக்கிட்டு அது என்ன பண்ணும், ஓகே அந்த கிராஃபாக நமக்கு அவுட்புட் வரணும் அப்படின்னா you need a proper data exchange. That is happening in STEP. So it means that you can implement big data, but that's not happening in IGS. Okay. And what is the architecture of this? So this is given with respect to the OSI layer. So here you are defining different layers for your STEP to bring out the application, to bring out the outputs. What about the applications? Application layer, large layer, and you are defining the physical layer. What about physical layer? Physical layer is making communication directly with the customer side. Okay, so from the customer you are getting the raw data, and based on the raw data you are going to implement your proper task. And is given to the generic entities and application specific entities. Yes, அவன் என்ன சொல்லுவாங்க, கஸ்டமர் எனக்கு இந்த டேட்டா இருந்தால் தான் இதை தான் கரெக்டாக வேணும் அப்படின்னு சொல்லிட்டு கேட்பான். ஸோ அவங்க என்ன பண்ணுவாங்க, அதுக்கேற்ற மாதிரி நீங்கள் கொடுக்கலாம். அப்படிலாம் ஒரு சிலர் வந்து பார்த்தீங்கன்னா ஓகே சார் இது என்ன அப்படிங்கிற மாதிரி கொடுக்கலாம். ஸோ here the entities of the ரெண்டை கிளாஸிஃபை பண்ணிட்டு according to that you are bringing the application layers. So application layer வந்து ஸ்பெசிஃபிக்காக கேட்டாங்க அப்படின்னா அதுக்கேற்ற மாதிரி உங்களோட டிசைன்ஸ் இருக்கும். Very clear from this diagram? All of you getting this? And what about implementation of step? How do you implement the steps? So that is happening unit is called Express. So Express is an entity. Entity is a collection of data, constraints and the operations. I already told you what is your data. So the data collect பண்றது அப்படிங்கிறது வந்து it's not easy job. So that's why the term is coming constraint. So constraint அப்படிங்கிற term வர்றதுக்கு காரணம் தான் அதே மாதிரி operations. So what the level இருந்தா அவர் வந்து டேட்டாவை கொடுக்குறாரு அப்படிங்கிறது முக்கியம். So Express அப்படிங்கிறது வந்து பார்த்தீங்கன்னா is a unit. Based on that unit you are collecting the data and is given to the physical layer of the system. So the data structure and file format. So after getting the data structure and file format for the customer specified one is given to the entities. Here you are defining generic entities and the application entities. So based on that coming to the application layer, you can define the different discipline. Discipline 1, discipline 2, discipline 3, and so on. Okay. Thank you.
So what is flag, sir?
For crossing a road, what are the rules and regulations you have to follow? The next one, the receiving engine should be ready to receive the data. So then only the data transfer can 0001, and at the receiving end, if you are receiving 1111, what happens? 2 bits have been changed, isn't it? So it results in error. Okay, you can't retrieve the original data. Okay, then communication settings. Okay, next. Please go to the slides. Sorry, to the slide. In the case of a communication system, there must be a sender and a receiver. Okay. Protocol, it is a set of rules. Handshaking. Then the protocols will determine the speed of transmission, error checking method, size of bytes, and whether synchronous or asynchronous. What do you mean synchronous transmission and asynchronous transmission? You know, studying about synchronous counters and asynchronous counters. Digital electronics. If it responds to a clock pulse, then it is synchronous. Okay, simultaneous transfer data. Okay. What do you mean asynchronous? What is the drawback of asynchronous transmission? In the case of asynchronous transmission, more delay is introduced. Okay. So those are all the protocols. Basic components of a communication system. Every communication system has 5 basic requirements: data source, transmitter, transmission medium, receiver, and destination. That's where the data will be placed. Okay. What is the data source? The information that is to be transmitted. Okay. Sender or transmitter, it transmits the data. Okay. So before transmission, the data will be coded. Okay. Then in between the transmitter and receiver, will be having the transmission medium. Okay. It may be free space or fiber optic cables, coaxial cables. Okay. Then the receiver. Okay. Next. Illustration. Next. These are all the important terms, okay, that determine the transmission media speed, bandwidth, the amount of data which can be transmitted on a medium over a fixed amount of time. It is measured on bits per second or bar. Then bits per second, bps, a measure of transmission speed. Then bar rate is a measure of how fast the change of state occurs. Okay. So if the bandwidth is less, what happens?
The data transfer will be very slow.
Okay, slow transmission. Okay. Then, for example, from the sending end to the receiving end, 20 packets are to be sent. Okay. If the data rate is very low, okay, transmission speed is very less, what happens? Only a few packets will be sent. Okay, and the remaining packets will be lost. Okay, so it will result in error. Okay. Next. Packets. Please note down. Transmissions are broken up into small units of data transmissions called packets. Okay. You have a large volume of data. Okay. It is broken into 20 pieces or 50 pieces of fixed size. Okay. And the fixed size data is called as a packet. Okay. One by one, the packets are sent, and by sending will be simultaneously receiving the acknowledgement from receiving. Okay. For example, if a particular packet is lost, okay, you can get the data. That can be resent to the destination. Okay. Next. 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 You know, studying about this OSL layer model, isn't it? Okay. Next. So these are all the important layers present in the OSI reference model. Okay. The lowermost layer is physical layer, the data link, network layer, transport, session, presentation, and application layer. Okay. What do you mean this physical layer? check some cycle condensation. Okay. So using these methods, you can find out the errors. Okay. Next. Next. What are the examples of communication systems? In the beginning, 100 years back or 150 years back, point-to-point communication, isn't it? Okay. The service was used in military, okay? Different applications. Then, okay.
Ham operators.
Yes. Then, any other types of communication? You know, heard about telegraphy, telephony, okay. Then, have you heard about the initial telephony systems? 10-line exchange, 100-line exchange. Any idea? Trunk call. So in English, nada, interaction, nada. What's the difference between 10-line exchange and 1000-line exchange? Which one is better?
1000
1000 lines. Why? At the time? 1000 connections can be established. But 10-line exchange, 10-line exchange na A to B, then C to D, then E to F. Only 10 connections can be established at a time. Okay? Suppose 11 connection or 12 connection, what happens? Cars are blocked. Okay? For example, but trunk call முன்னாடி காலத்துலலாம் வந்து half an hour ஒருத்தங்க பேசிட்டு இருப்பாங்க. அப்புறம் next person will be waiting for another half an hour. Suppose என்ன ஒரு 5 or 10 members இருந்தா வெச்சுக்கோங்களேன், ஒரு டெப்த் இன்ஃபர்மேஷன் கொடுக்கணும். பண்ண முடியுமா? முடியாது. Okay? So calls are blocked due to network resources. Okay? Nowadays இத ஓபன் பண்ணிருக்கோமா இல்லையா? பண்ணிருக்கோம். அது ஸ்டெப் பை ஸ்டெப்பா போறோம். 100 exchange, 10,000, 10,000. அப்புறம் இப்போ now we are using mobile cellular communication systems. What are the advantages of using mobile cellular communication? Or cellular communication system? What do you mean by cell?
Conference communication.
What do you mean by cell? Cell line.
It's a type of receiver also.
Oh. Cell represents cell in mobile unit cellular communication is cell. It represents a small geographic area. For example, the Avadi area. So Avadi, Vellanur, then Manikan Sakarama, then Veerapuram. So some villages. எல்லாமே ஒவ்வொரு செல் வச்சுக்கோங்க, 7 clusters. சரியா? So in the 7 clusters will be using each cell will be using 100 frequencies. சரியா? These 100 frequencies can be repeated in another cluster located in suppose Gindi area or in Sholin area. Okay. So what happens? Frequencies are reusable. Okay. So thousands or lakhs or crores of calls can be established at a time. புரியுதா? முன்னாடி அந்த டெலிஃபோனிலலாம் பாத்தீங்கன்னா 10 calls or 100 calls or 1000 calls இல்ல unlimited calls can be established. சரியா? Okay. Then what about this type of communication? Optical fiber communication. What are the basic components of optical communication system? It has a sender and a receiver in between optical fiber communication medium. Okay? Then what about sending in? Here are some information. Okay? That is to be sent to the receiver. Okay? We will be using LED, light emitting type. Okay? If you have to send the data 1, it has to be turned on. Okay? So you have to apply fibers. Then it will be turned on. Current passes through the device. Then what happens? It emits light. Okay. Then if 0 is to be sent, what happens? We need not apply signal to LED. Okay. The light will be in the off state. Okay. So light signal will be 0. Similarly, the data is coded and it enters through the optical fiber medium. Okay. What about the propagation of light through the medium? Total internal reflection. Okay. What about the loss of signal? Practically 0. Okay. So efficient way of transmission. Okay. Then have you heard about satellite communication? What is the need for satellite communication? Or why do we go for satellite communication system?
There is no disturbance. It's a direct to atmosphere.
சரி நான் இருக்கேன் ஹிமாலயாஸ் இருக்கு மேடம் இருக்காங்க ஸோ டேரக்டாக லைன் ஆஃப் சைட் ப்ரொபகேஷன் இஸ் பாசிபிளா இல்லை இன் தட் கேஸ் டேரக்ட் data is directly sent to the satellite the receiver sends okay so presence of obstacles have no effect here okay next you are studying all these things okay analog digital next serial transmission. Data is transmitted on a single channel, one bit at a time, one after another. Much faster than parallel because of wave-based process. Okay. Serial transmission. One by one data is sent. Okay. Next, parallel. Next is this. So this is parallel transmission. Each bit has its own piece of wire along which it travels. Often it is to send data via particular. Okay. Go to the slide. So parallel transmission is the parallel. Okay. Next. Let us see. Next. Transmission direction. Okay. Simplex. One direction only. This is sender. And this is the receiver from sending end to receiving end. So in this direction, okay. Then from receiver to sender, it is in the opposite direction, okay. So simplex. Okay. Next, off duplex transmission. So in case of off duplex, both directions, but only one direction at a time, okay. In a telephonic conversation, okay, at a time one, okay. Next, full duplex transmission. Send and receive both directions at once. Okay. Next. So these are the common protocols. Next. Ethernet. Next. 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 Okay. Examples of LANs. Local area networks. Okay. 3 different types of LANs. Topologies. Okay. Right. First, because study visited. Okay. Go to the another video. Standards and standards are developed by cooperation among standards creation committees, forums, and government regulatory agencies. Standards are developed by cooperation among standards creation committees, forums, and government regulatory agencies. So these are all the various standards creation committees: ISO, ITU, the last chapter is ISO standard system. Next slide. International Standards Organization. A multinational body whose membership is drawn mainly from the standards creation committees of various governments throughout the world. Currently includes 82 memberships of industrialized nations. And it aims to facilitate the international exchange of goods and services by providing models of compatibility, improved quality, increased productivity, and decreased prices. What's the relation between price and productivity? Price and production?
Productivity is more. Prices is.
Yes. For example, if you are producing 1 crore chips, what is the cost of a single piece? Be very less. Okay? If you are producing only 10 items, more prices will be for a manufacturer of single items, isn't it? What's the definition for quality?
Fitness standards. To the standard.
Fitness for use.
Fitness for use. Satisfying the demands of customer. Okay. So improving the quality means
Enhancing the features.
சரி ஒரு மொபைல் ஃபோன் எடுத்துக்கோங்களேன்.
We are giving
Extra features நீ கொடுத்தீங்கன்னு வச்சுக்கோங்களேன். It will attract more customers. Okay? More number of products will be sold. Okay? Then it results in increase in revenue. Okay? Yes. Next. International Telecommunications Union (ITU), also known as International Telecommunications Union Telecommunication Standards Sector (ITU-T), an international standards organization created by the United Nations to develop standards for telecommunications. Two popular standards developed by ITU-T are E-series and F-series. Okay? Transmission over public digital networks, email and data services, and ISDN. Integrated Services Digital Network. Okay? ISDN. So only for telecommunications. Have you heard about modulation, types of modulations? Modulating signal, carrier signal, AM, FM, PM. Okay. What is modulation? Modulation is the process in which the characteristics of a carrier wave is varied in accordance with the instantaneous value of the modulating signal. Okay? So in the case of amplitude modulation, amplitude of a carrier wave is varied in accordance with the instantaneous value of the modulating signal. In the case of frequency modulation, frequency of the carrier is varied in accordance with the instantaneous value of the modulating signal. Clear? Okay. That is, you will be having a low amplitude, low frequency signal. That is the modulating signal. Okay. So this signal contains the useful information that is to be sent. Okay. For transmission purpose, you are in need of another high frequency signal. That is carrier wave. Okay. So this low frequency signal is superimposed on a high frequency carrier wave. Okay. So that using antennas, the signal can be easily sent. Okay. So what are the requirements for a carrier wave? It should have higher frequency range. Okay. In terms of 100 MHz or 1000 MHz or gigahertz like that. Okay. If it is less, what happens? The antenna height will be in kilometers. Okay. Or if you are using 100 MHz or 1000 MHz signal, the antenna height will be less, around 10 meters or 15 meters. Next. American National Standards Institute, ANSI, a non-profit corporation of Electrical and Electronics Engineers, IEEE. The largest national professional group involved in developing standards for computing, communication, electrical engineering and electronics. So it aims to advance theory, creativity and product quality in the fields of electrical engineering, electronics and training. So these are all the standards, okay? 802.3, 0.4, 0.5, 0.11, 0.x. Next. Electronic Industries Association, AIA. An association of electronics manufacturers in the US, United States. Provide activities include public awareness education and lobbying efforts in addition to standards development. Responsible for developing the EIA 230, EIA 530 standards, okay? Serial communication interface standards. Okay? 10 years back it was RS 232C. Okay? These are other improved versions. Next. Internet Engineering Task Force. Concerned with speeding the growth and evolution of internet communications. The standards body for the internet itself reviews internet software and hardware. Next. Communication protocols. Protocol is a set of rules that govern all aspects of data communication between computers on a network. These rules include guidelines that regulate the following characteristics of a network: access level, allowed physical topologies, types of cabling, signals, the speed of data transfer. So protocol defines what, how and when to communicate. Okay? So the key elements of a protocol are syntax, semantics and timing. If the timing is not followed properly, what happens? Communication will be late. Yes. For example, for a dance program, music இருக்கு plus audio and video இருக்கு. ரெண்டும் ஒரு synchronize ஆகுதுன்னு வச்சுக்கோங்களேன். First music வருது, அப்புறம் ஆடுறாங்கன்னு வச்சுக்கோங்களேன். ஒரு 5 seconds later 5 seconds இருக்குமா? இருக்கு. synchronization இருக்கு. புரியுதா? The problem. Next. So these are the common protocols. Note பண்ணிட்டீங்களா? Let's just go. Getting will be familiar with point-to-point, file transfer protocol, SMTP, and HTTP, was in order. Okay, TCP. Okay, so next. Network protocols. SNMP is Simple Network Management Protocol. Okay. Next. User Data Protocol, UDP. Next. Virtual LAN. So logical grouping of network devices or computers. Next. Routing Information Protocol, RIP. To provide routing information. Then OSPF. Next, quality of service. This is very important. QoS. Okay. Network management of traffic. Requires traffic management of network, particularly during times of congestion or failure. Quality of service also give preferential treatment if the node does not reach the work levels due to the packet transmission. Okay.
my PG in CET, so most of you know. And even though this FDP is regarding computer design, but we cannot isolate this thing because the CAD itself is under inside this thing, right? So being the last session, I would just want to have an interactive session because everyone is familiar of SIM, isn't it? So irrespective of the specialization in your PG, all of you would have at least known about what is computer integrated manufacturing. And this computer integrated design, so when we talk, so before some 30-40 years before, we don't have much influence on the computers as the first generation of the computer arose in 1960s only, right? So after this influence, I mean, after the invention of the computers and other calculating machines, so they played a vital role in the technological developments and also in our engineering field. And slightly, that influence of computers it has its vital role in design and slightly move on to the manufacturing. And finally, the evolution of the SIM concept, that is computer integrated manufacturing. So that allows, so most of you, that is most of the persons who are studying the SIM in the UG level, so they would have known what is SIM. But some, for example, some 7 years or 8 years before, so most of us won't be knowing about what is SIM, right? So can anybody say what is SIM? That is what is computer integrated manufacturing. So this is just, don't mistake me. I am not asking questions like staff or a student. Just I want to have an interactive session. That's it.
They are integrating computer in the manufacturing.
Yes.
To improve their productivity, profit,
Okay.
reduce the idle time, to save human.
Okay.
To reduce human effort.
To reduce
Human effort.
human efforts. Good. So everything is, see, whatever you say, everything will come under computer integrated manufacturing. Because if you say this is a CAD or CAM, it is specific. So CAD is only the use of computers for designing, and CAM means its use of computers in manufacturing. And still, we need to know what is the difference between the production and manufacturing. So there itself we need to go in depth. But since I don't want to extend this session because all these concepts what I am going to show is familiar to you already. So I want to have a general exposure about that. So can you say what is the difference between production and manufacturing?
So in the case of production, we are not doing any value added activities in the material.
Okay.
We are using the material as a user-defined ideas directly, when we call it as production. So as in the case of manufacturing, we are adding some value to the raw material. We are making our raw material final user-defined state, that we call it as a manufacturing.
Yeah, of course.
We are producing food products and nature, that we call it as a production. See, for our sophistication, we have a charge system, computer, fan, etc. that we call it as a computer manufacturing.
Okay, so thanks for your answer. Anyway, so whatever he is trying to give, so that is almost correct. But to be specific, the production is in a single word. We can say the production is just a conversion of raw materials into finished goods. So 95% the production is only the software activities where, so before procuring the raw materials and after the finished goods, we will be dispatching the finished goods either to the store or warehouse or wherever we be, right? But those will not come under this production. So production is an activity where we convert the raw material into finished products. But the manufacturing, right from your planning, suppose you want to do a job, or you are going to make a component, or you are going to make a particular system which comprises of most of the components. So then, every stage we have production activity, right? For example, if you take an automobile, for each and every component. So that requires the production. Production in sense for that particular material or component. So we need some raw materials, and that particular raw materials to be converted into the finished goods. That's it. So this activity will say production, and this manufacturing, it involves right from the planning, procurement of the raw materials, and the final dispatch, and also not only the dispatch, the marketing to various, that is the marketing the commodities, okay, the society till the end user, right? So there we say that is manufacturing. So now I think you are clear about what is production and manufacturing, right? Again, this becomes a new field where after this influence of computers, we are using the computers for the entire manufacturing activities. So even if you say, I said the first process is planning, so that planning we use computed process planning, right? So planning of the whole system, that is something different. Even to bring out that particular product, to finish good, we need to plan various processes for which we require the computers, and using the softwares we could be able to do this process planning with ease, okay, with less human interventions. So there itself, for a single process planning, we are using a computer, so that itself is said to be the computer-aided process planning. And regarding the inspection, most of you will do the inspection, right, by human observations, by measuring the instruments or whatever the measuring instruments or the inspecting equipments, okay. But when we have an intervention of this computer, so that particular inspection, so we say that is computer-aided inspection. Okay, like that. So at each and every step or each and every process, we use the computers, okay, so to bring out the products with the quality and the customer requirements, and also at the fast. I mean, at the fast max. That's what. So I will just I will see these slides one by one. So we should be just taken from the standard textbooks. So it's already available in your various textbooks. So no need to copy this also. This also, I think your CD will not have this content, right? Since it is not required. So we'll just see what is the CAD, CAM, and Sigma. So what do you mean by CAD? What do you mean by CAD? Yes? Design of
modifying the product.
Yes, generally. So designing in sense whatever the already existing product we may be able to modify it. So that modification is also called as design. That's it. Okay. So not only the new inventions or innovations, whatever the already existing product, that also when we do some small modifications, that will come under design. And in our author's world, computer design means the use of computer to assist in the design of an individual part or a system. So whether you go for a small thing or nut or bolt or a small washer, or you want to go for a big system, whether it is an automotive or aerospace or wherever the application is. Okay, so when we need the assistance of the computers, so then we can say that is computer design. So the process usually involves computer graphics. So already most of the resource persons for the last 6 days they have given you a vast thing about the computer graphics, because this computer design almost consists of what? Computer graphics, right? So we'll be just using COE or Creo or Access or whatever will be the software which is available for us. But we will be just user end. We'll be at the user end. We are not at the developer end. Okay, so we need to know what are the interfaces between the user and the computers, and also the various nomenclatures, the standards, the computer standards. So everything, okay, that will come under this computer graphics. So there you will have seen. And the CAD system supports design process at all levels. At all levels, in sense, what are the preliminary things Yes, sir. Final design is what automates are finalized. Okay, so this is, and next one is you'll see what do you mean by the cap. So all of you know in CNC machines. So why it is called as CNC machines? Yes. So this is actually the computer numerical control, right? Computer numerical controlled machines. So that is said to be the CNC machines. But before that, we have one more thing, that is a DNC, right? Yes, direct numerical control. So can you able to just recall the concepts? What is DNC and CNC?
Direct numerical control, there is a for each one manufacturing machine, it has single control. For CNC, it's one single computer
Which can control entire machines, So in advanced, so this CNC machines, advancement of this CNC machine is said to be the FMS, right? Flexible manufacturing system. So we will be able to control various machines sitting in one place. And this CNC machines, this FMS, in which industries you can find? Hyundai. All automotive industries. So here the software itself, they will have various classifications, like say this is actually single machine cell, you can say, where we have suppose one wire cutting machine. So you will be able to generate crores and crores of profits out of a single machine. So that cannot come under a software environment unless it is just present along with some other machines in the software. Okay, it occurs in a small room. Okay, so there we can say this is a machine cell. And moreover, we have FMC and FMS. What is FMC and what is FMS? Cell. So what would be the difference? Yeah, only maximum 3 machines we can have in a FMC, that is flexible manufacturing cell. Whereas if the number of machines exceeds more than 3, that is from 4, it comes under flexible manufacturing system. So that is the thing. And next. So the computer manufacturing is the use of a computer to assist in manufacture of a part. So why it is restricted to a part, not for a system? We cannot manufacture the entire system at a single stroke, isn't it? So we have to go one by one with each component, and finally we have assembly. So that is why the soft floor, the assembly shop, right? And flexible flow shop, perpetual flow shop, hybrid flow shop, like this. The shop environment itself will have various classifications. Okay, depending upon the nature. In a flow shop, for example, I tell you what is a flow shop and what is a hybrid flow shop. Flow shop in sense, all the machines will be arranged in stages. Okay, at each stage, suppose we have some k number of stages. At each stage, if you have only one machine, suppose you want to have, if you want to manufacture, or if you want to make a component, say a rod, single rod. So first lathe, so what we do, that will just turn it and face it, and it will give it. The next stage, that machine will do some taper turning, and next stage, that will do some threading. So like this, if finally that would be put into the heat treatment, so that would be kept in separate, soft floor or separate unit. But even though when it is continuously, so step by step or each stage by stage, if the process is done, that is said to be the flow shop. And the hybrid flow shop means, suppose you have 10 number of stages, if any one of the stage is having more than one machine, it doesn't mean that all the stages should have more than one machine. All the 9 stages may have a single machine, but any one of the stage, if it has more than one machine, then that type of a shop is said to be hybrid flow shop. Okay, so like that. So in Hyundai we have all these kinds of various shops, and that's why this Thus, it's restricted to a part. Okay. Next one. The CAM technology is concerned with three main areas. One is numerical control. So in the first generations, actually we used punched tape. So it's not like our whatever existing now. Okay. Previously they used punched tapes, and from that now the new era is using the numerical control. The two is computerized numerical control. And we have process planning. That is very, very important. At each stage, the plan is very, very important, and the monitoring of the particular plan is also very, very important. Because any variance, if you deviate from the production or manufacturing, okay, we cannot suddenly control or we cannot immediately take decisions because it is completely computerized, already planned, and everything is programmed. If you say in Nokia, one accident has occurred, right? Have anybody else heard of that? Not in Nokia, but in Sriperumbudur, one of the industry, or the mechanical manufacturing industry. One girl was thrown out of the shop, hit by a robotic. A robot. Because if you see, how many of you have visited Hyundai? Sorry, just for. Have you seen? Have you visited Hyundai? So Hyundai is a company where we have 95% automations, only 5% manual. So everything is automated, even right from the welding or sheet metal work or painting or assembly of the human intervention is required only to a few levels. Just the robot will automatically they will insert the screw, they will tighten the screw, they will take the door, and it will just move to the particular. Actually, there will be a flow line. The car with the semi-assembled stage it will be moving slowly, and the time is calculated, and everything automatically the robot which is programmed and ready that will do the job. Okay, suppose if any one of the robotic machine is getting affected or it just break down, so suddenly we cannot control. And sometimes that robot may not move and the human cannot simply enter because suddenly suppose if it gets some signals, what happens, it will automatically continue its job. That time if you go there, automatically will be thrown out. So we have that much problem also. And the drawback is when you want to rectify that particular problem, so either you have to disconnect that particular robot from the system, or you have to stop the entire system and you have to rectify the defect, and then you have to continue the job. Okay, so that is the thing. And since this process planning is also needed at each and every step. Suppose if it happens, what to do the next? So that should be predetermined. Okay. Next one is, let us come to the concept SIM. What is SIM? I already told you. So the manufacturing is right from your planning to till the dispatch to the warehouse. Then after that the business process will be there. That is marketing, right? So everything will come under this manufacturing. But even though there is a small gap between this manufacturing and marketing, so marketing itself is a big concept. But we cannot neglect that concept from the manufacturing. So that is also one of the final stage of what your manufacturing activities. Yes. So it encompasses the entire range of product development and manufacturing activities with all the functions being carried out with the help of the dedicated software packages. So since we are using most of the software packages for the planning, but also design and manufacturing, and even for marketing also and business also, we are using the software packages. So that is why it gets the name computer integrated manufacturing. Okay. The next one is, it uses a common database where feasible and communication technologies to integrate design, manufacturing and associated business functions that combine the automated segments of the factory or a manufacturing facility. So that is very important. So we need a common database. Suppose the data which is relevant to the purchase, the data which is relevant to the manufactured or finished goods is kept somewhere else. Okay, we cannot have an integrative knowledge of all those things. So everything should be under the common database. So from there only we can share. Suppose for example, the purchase department, if they are procuring materials, for example sheet metal they are procuring, and the manufacturing or the particular sheet metal work is done in somewhere else or some other shop floor within the factory or within the company, that person should have the knowledge of how much stock we have. Then only the manufacturing people or the production people can plan the next production activities. Without knowing the knowledge of, without having the knowledge of what stock we have, he cannot take decisions. So everything is integrated. Okay, so previously we had oral communications actually between the stores and also between the production shop that we have this much material, we have this much material. But now everything is computerized. Suppose you have the interlink with the various shops with the land. Okay, so with the software, the sophisticated software, the productive people or production people can easily able to access what stock we have. So what we need to plan for the next day activities. So like that. So it becomes very easy, and it reduces the human interventions, it reduces the time, and it reduces everything in sense. So now the customer requirement is the delivery on time. The quality, that is first, the cost, that is second, right? Third one is the delivery on time. That is very important. So now the ambassador car, whether it is available or we can directly go on to purchase or directly go on get a car immediately, I am saying. Even some two-wheelers, you cannot have the immediate purchase of that particular item. Why? Because now it is going in a reverse manner now, this marketing. Actually, depending upon the customer requirements, the product is manufactured. Previously, 1,000 cars would be manufactured at a time, and according to the different colors and everything, so according to that, whatever available, the customer will go and get a particular car. Now it becomes reversed, like whatever the requirement of the customer, according to that the manufacturing is done. So this becomes easy and it becomes very easier. Why? Because of this interventions of the computers in the field of manufacturing and also this design. Okay. So here, next. The data record for various functions are passed from one application software to another in a seamless manner. That is also very important. There should be no loss of data. Suppose you are designing a particular component using a CAD software and you are going to manufacture it by importing that software into that manufacturing, like Mastercam or whatever maybe Unigraphics, anywhere else. If suppose your specification and some of the data are lost, your final output product will not be as per your design. So the loss of data should be avoided. That's what I say. For example, the product data is created during design, and the data has to be transferred from the modeling software to manufacturing software without any loss of data. Suppose if there is any loss of data, then there is no meaning of designing, isn't it? So whatever the final output product, so that itself will be the final. So it's not as per, it will not be as per our design. Next. It also encompasses a whole lot of enabling technologies, like you say, quality management. This quality management itself is a big area where in each and every part, or each and every step of your process or the every department, we need to impart this total quality management. That is continuum concept. And the business process, re-engineering, concurrent engineering, workflow automations, the enterprise resource planning, and the flexible manufacturing. So you are familiar, I think you are familiar with this enterprise resource planning, right? One of the software is also very familiar in the markets, ERP. Enterprise resource planning. Can you give some more comments on this ERP? It was heard about the SAP software, SAP training programs. So this is only this is one of the ERP software actually. So nowadays the companies are not willing to concentrate much on the supporting activities like your purchase or warehousing. So warehousing, none of the big companies will have it in their own concern. They will outsource it. Can you understand? Suppose you are manufacturing some 10,000 cars and it should be supplied to various parts of the country. So we cannot hold all those 10,000 cars in a particular place. So we need to go for warehousing at different locations. So the company cannot spend much money to establish or erect that warehousing wherever they are required. So they will give it to the private body. Some 1,000 cars will be supplied to somewhere else, 500 cars will be supplied to somewhere else. Like this, all these 10,000 cars will be supplied to different parts of the country. From there, nearby, according to the requirement, nearby areas, they will be supplied. But every day there will be purchase activities, there will be some delivery activities. But how the company can control it, how the company can monitor it, using ERP, right? So there will be a private body where they will monitor all these activities and they will intimate then and there to the companies. It's not only for dispatching and also for the purchase activities also. So suppose some of the materials will be got from China or some other countries, or all those materials cannot be dumped in one place. So it needed to be, suppose a car at a semi-stage, you cannot say car, maybe you can take automotive industries also. So the final furnishing, the luxurious things what the customer requires, everything cannot be fit within the company. So they will give a basic model, that's it. Okay, with the basic sheets and other things, the colors, the cushions, or whatever may be the additional accessories and the requirements they need. So that will be done there itself. So that is why we have various service centers. Right? Even if you go to get a bike, the extra fittings, right? They want to supply along with this. For that they will be charged extra. Isn't it? So those materials, suppose if it is a unit run or company run unit, so they need what about the requirements of the particular component or particular accessories. So they have to monitor them and then. Suppose there is less stock, they have to supply immediately. Sometimes it may take 1 hour, it may take 1 month. So according to that they have to plan. So there is the planning activities are there. So everything will come under the severity. And you know what is concurrent engineering? Concurrent engineering, I think all of you will be familiar. So that means simultaneously most of the process will be done and it will be assembled at a single stage so that there will be some time reduction. Okay, next. A distinct feature of manufacturing today is mass customization. So that is a very tough thing. We have, according to production, we have mass production, batch processing, isn't it? So batch processing is discrete. Suppose you need a particular component under some standard size, it is required to only 50 numbers. So that 50 numbers will be processed in batch and it will be finished. And again they will go for some other component which has a little more bigger size or according to their specifications. So this mass communication, customization, that is what I said previously. What they did, they will manufacture 10,000 or 5,000 cars per year, and they will supply it from the place of manufacturing. Right? So that is the next. And this implies that though the products are manufactured in large quantities, products must incorporate customer-specific changes to satisfy the diverse requirements of the customers. So that's what the next slide will be, the challenges which is faced by the manufacturing engineers or the production engineers, because the customer satisfaction is very important and the customer requirements also varying then and there. Suppose now I need a car of some maroon color or red color. Okay, suddenly my mind may change. Suddenly I can tell the supplier that no, I need some other color. So that means that if the human mind changes and the requirement or wish are different, okay, so according to that we have to manufacture and we have to supply. So that is very difficult task. Okay, so this requires extremely high flexibility in manufacturing system. So that's what the challenge is before the manufacturing engineers. Now the industry is trying to reduce the cost of the product continuously remain competitive in the face of global competition. Suppose Mahindra is introducing a new version, immediately the Bajaj, next to this Hero Honda or some other TVS. So they want to change. See, previously you would have known CD100, right? So for how long years it was in the markets? The same model. Hero Honda previously, it was in the market for nearly 10 years, right? Even the Splendor also, not Splendor Plus, the Splendor. So it was available in the market for more than 9 or 10 years, right? But now you just see the marketing scenario. Every year new model is coming, right? That time, suppose the Splendor has introduced a new model, new features. To overcome that feature, the other company will start research after seeing that only. Then they will go for R&D, and it will be finalized in some 1 or 2 years, and they will search for the materials and other things and the facilities, and they supply for the, they will search for the vendors who can supply the particular components, and every year. So to finalize this will take years. But it is not now. Now it is not like that is. Okay, so within a month or 2 months or 3 months, within a year, they can launch 2 or 3 models. So that is happening because of this computer integrated manufacturing. Next one is there is a need to improve quality and performance levels on a continuous basis. It doesn't mean that only just one product is supplied with good quality. The next one we can go as we like. So the continuous, it should be continuous. So that's what the quality and performance levels should be on continuous basis. Another important requirement is now time period. Because suppose if you delay, suppose you are the supplier, if you delay, even we people are mechanical engineers, now we are going for new machines. So one of the machine, we don't have manufacturing facility in our India, but even though we have put purchase order. So Rajmanikam will know. One of the machines in our manufacturing technology too. No, I am saying one of the machines. Shaper. We don't have manufacturing facility. Now only they are going to suppose if that particular company delays, suppose they have promised us to supply within 6 months. If they get more than 6 months, by seeing this demand, if another company just they want to start the units and they could be able to supply it earlier, so where we go? We'll cancel this order and we'll go to that particular company. So that is the thing. So this time delivery on time, that is also very important and very challenging thing for the manufacturing engineers. And in the context of the global outsourcing and long supply chains, across several international borders, the task of continuously reducing delivery time is really on adverse task. And our SIM has several software tools to address the above needs. That's what I said, right from planning to till it gets dispatched, or after that also, and the marketing, we have this influence of various software packages. It's the objectives of the SIM. First one is the reduction in inventory. So why we are going for this ERP software, especially for this, because in ERP also we have purchased the material handling, or manufacturing, healthcare, accountancy, all those things we have different softwares. Okay, and lower the cost of the products, because to compete the market, and reduce waste. Again, we are going for the lean and this, and to improve the quality. Next. So increasing flexibility in manufacturing to achieve immediate and rapid response. That should be very important. See, suppose you are a service people. Suppose your product is to be serviced immediately. Okay, so you have to give the service on time. Otherwise, he may not be satisfied. He are not going to replace the product, but he may say some other process that the service is not good, the product is not good, so better not to purchase that. So that will definitely bring down the company's attitude, and that's what. And these manufacturers should be ready to face the product changes, the production changes, and also the process change, the equipment change and the change of the person. Next. And here some of the SIM hardware and software which we are using. So most of you would know some of these softwares. And here this is a manufacturing equipment such as CNC machines, which is a vital part in our SIM, and robotic process. So as I told you, if you go to Hyundai or Renault, Nissan or whatever with automotive industries, so most of the work is done by the robotics. So without robotics, this integration of, FMS. That's the thing. FMS is the next stage. But we need CNC machines and robotics. Okay, they play the vital role in any manufacturing activities like this big industries. And the work handling and tool handling system, that is also very important, because the material handling will also require, suppose to make a component it requires some 5 people, but to transport the material to one place to another place it may require 10 people. So that means that the transportation or the material handling is also very, very important. Storage devices and sensors. See, this particular sensors, even in manufacturing also it has its own contribution. And in the inspection, the sensors, very, very important. So you know various sensors, right? Tactile, touch sensors, other sensors. So to check the, suppose if you have a Coke bottle, to check the level of Coke or Pepsi filled up in the bottle. Okay, the human cannot have that exactly, but the sensors can monitor and it could easily identify the deviation in its level. Okay, so I told you in computer-aided inspection. So there we have both sensors and the shop floor data collection devices and also the inspection machines. So inspection machines in computer-aided design we have various things. Yes. Since it is costlier, in our mind it will come first. Okay. Next, the computers and controllers as we know, CAD/CAM systems, workstations and terminals, data terminals, barcode readers, and also the printers and plotters. So you know what is the role of barcoder, right? So the identification of parts would be done not with the name, with the codes. Okay. And the other peripheral devices like modems, cables, and the connectors. Now the SIM software. Yes, right. Compressor of the computer programs carry out the following functions: management information system, that is MAS, marketing, finance, database management, modeling, design, analysis, simulation, communications, and auditing. Okay, so all these things I don't want to explain much more because you are all professors, so I just wait this. Also, this production control, manufacturing area control, even for job tracking. Suppose you have a big industry, suppose a particular product is moved from that particular shop, but it has not reached to the next level. But it may have some other, it may have some problem in between those two areas, isn't it? But the tracking of job among some thousands of jobs, okay, so that is quite difficult. So there also we need some job tracking and software data collection, handling. Okay. This major elements of a SIM system. Okay, so we have 9 major elements, and first one is marketing. So whatever the product you manufacture, if you manufacture it or you produce it, if you keep it in the store or the warehouse, there is no use. For each day, if the interest is calculated, the company's profit will be reduced. So as we marketed, product design is very important, the planning, purchase, and manufacturing engineering, that is manufacturing, and factory automation hardware, warehousing, logistic and supply chain management, that also a big vast area, finance and information management. So these are the various activities in SIM, and we were able to please. You able to see that even we have a tool design also, not only component design for that machining particular tool. If you want to design it, that is also very important. So every activities which involves right from the purchase to right from the planning to till the dispatch. Okay, if the computers are used or the intervention of computers are there, then it is said to be SIM. Okay. Then the simulation. Say I want to add this simulation only because previously the simulation before the invention of these simulating softwares, everything was done manually and physically, right? Even if you have a crash test after you manufacture a car, at what speed, at what load, whatever the damages you got in the car. Okay, so that is done manually. So you will be wasting a car. For full car, for obstacle, just you hit the obstacle and you just analyze after hitting the obstacle, you will analyze it, what are the damages, where it is, whether it will be safety to the driver or not. Everything will be analyzed physically. But now, there we have softwares, the sophisticated softwares, where you can say we can test this crash testing in the software. So we can pre-judge before we go for physically testing. We could able to justify which can give 80 to 90% accuracy. Okay, and these are the things. So most of the softwares you are familiar. Some of the softwares which are available in the market. Now some of the softwares which are not available in the market, but they will be available with the manufacturers. Okay, according to their requirements and specifications. And with this, I just completed my lecture on this computer integrated manufacturing tools. And if you want to ask anything else, please.
What are the software used for CAD?
CAD? Yeah, that's what actually that part we did use, isn't it? So far we didn't use, and we are not familiar on that.
Some of the software used for the CAD.
Yes. So I don't know that specific name because each and every company, suppose you take even designing software, the manufacturers are not using whatever the software which we know or which we are familiar. And the CAD, it is not available so far in any of the educational institutions.
Now they added that.
They have added and they mentioned that as adequate. So that's why we are not concentrating on that particular thing. Otherwise, suppose if it is required compulsorily, then we will search for some other softwares.
They added.
But it is not required, so they mention only it's adequate. So that's why I didn't go in depth at that. And I want to have a practical session, but due to some interruptions, I couldn't able to do that. Flexing Flexing. Just it is available in our net for free trial version. You will be able to download it and you can just practice it. Even for research also it would be very useful. Okay, so just I want to have a general exposure about this. Recalling all the concepts. I don't say that you won't know all these concepts. It is already there in your mind. Just I want to recall all those things. And this particular material is not available in your series, but it is available in our standard order books. Even if you take MS Bluer, it will be there, recordings. Right? And thanks for giving me this opportunity to handle this session. And if any queries, please.
Good afternoon, everybody. At the end of the Sunday's workshop, I feel honored to stand in front of you all and express a heartfelt thanks for your coordination and contribution in making this 7 days workshop on computer design approved by University Chennai. Very fast. I'm very much thankful to the Almighty for giving me the energy and the supportive faculty members of the Mechanical Engineering Department in organizing this the wonderful 7 days program. Very much thankful to the really Veltech University. Dr. Henry Xavier, Professor Rajamanikam, Professor T.V. Babu, Professor Vishnu Kumar from Veltech High-Tech Engineering College. Respectful resource persons from PTRS, Dr. Chandramohan, Professor Ram Kumar, and our internal faculty members, Professor Kumar, Professor Palani, Professor Tamarai Selvam, Professor Anandan of IT department, and Dr. Chevrani of IT department, from the department of IT, and Mr. Karthikeyan, HOD of CSC department, Dr. Kuppusamy of ECE department. If I missed any of the faculty members' names, please pardon me. That's it. And actual thanks to my friend Mr. Kapil Raju, Business Development Executive of I3 Solutions Technologies from Chennai, for their generosity in sharing their knowledge with this fraternity to motivate them and to impart their knowledge with you. Then my obvious thanks to all the valuable participants from various institutions, PTRS, PTHT, PTMT, St. Peter's College of Engineering, Velamar Engineering College, TJS College of Engineering, Magna College of Engineering, RMK CET, STCE. I can say this program would not be completed without their participation and their cooperation. We have organized this program only in the last minute with the support of very few faculty members of our department of mechanical engineering, like Professor Kumar, Dr. Palani, Dr. Jay Kumar, Dr. Sagamani. So there are some more people helped us in various to get the various facilities available in our institutions, like a catering people, Lokesh and very much thankful to Mr. Mohan Sundaram and NTS for this timely help to get this refreshments and the lunch. I hope you all released the lunch served by us. Then our Muniratnam sir for his punctuality in the even and sometimes I found him in the hall without even a single participant or the internal organizers. And that much dedication he posted on our program. Thank you very much, sir. And this Mr. Sasi Kumar, I have to thankful him also for his effort in making this program alive. Our internal faculty, I'm so sorry, other department faculty members, Madam Arnarsi, Madam Kalpana, and Arulmodi, Madam Arulmodi, for their Arulmeri, for their presence and their support. Even in the first day, like in the prayer, he helped a lot. Because I don't know the formality what you have to follow in the program. He on time he did it and made the inauguration function in a good manner. And my gratitude, heartfelt gratitude to Professor Kumar for his support in organizing the program from the very first day. He has contributed a lot in organizing our one-work program. We have conducted simultaneously along with this program, solid waste management from the early morning 7 o'clock. He went to school and he picked the students, he brought them to school, this campus, and they arranged all the things to them, and he made that without his support, definitely it was not possible for me to organize that wonderful, because at that day I enjoyed a lot. I mingled with the very, very chota bus, the youngsters. So sorry, very much thankful to the management. First I have to say this only, but I forgot it only. I have to thank the management for their support and for the permission they have granted to organize this program. Even without their with the permission, we cannot do this like this programs. Even though the university approved our program, without their support it is not possible. And then it's my pleasure duty to thank our principal and the dean, Dean Dr. Paksarthi, for his support and their valuable suggestions. The planning of this campus, and head of the Department of Mechanical Engineering and all the faculty members. Right? I don't want to miss anybody to express my gratitude. Right? Then this I have to give valuable feedback about our program. Whatever, so Master, we can criticize. This is not a platform for only, how can I say, we can frankly come and express your views about the program. In the direction of an organizer, you are not in a proper way. Good arrangement, whatever you think in your mind, please come forward. Because then only we can improve ourselves. But if you say all positive means, definitely that will suppress us only. We cannot get any venues to improve ourselves. Yes, sir, Rajamarkim sir. And Rajamarkim sir and DVV sir, when I contacted him for organizing this program, for scheduling the program, that two people immediately came to my room. Sir, when you were present in the room, they came immediately to Dr. Henry Xavier. For his age, he need not come to my room. Right? He came to my room and he discussed with me and he fixed the topic for his presentation. Right? Very much, I felt honored on that day. I am very much grateful to them also. And Professor Veltech Multitech, when I was preparing the schedule and the various, when I outlined the various activities of the program, he came and helped me. When I fixed the resource person, he came and helped a lot in fixing them. And Professor Selvamani, every time he will encourage us, but he will exaggerate something. But whenever he used to say, "Madam, you are good, you are doing like this way." That way only he will. And the generosity கூட வேணும் தானே. ஒருத்தர் ஒரு வார்த்தை பண்றாருன்னா that appraisal, encouragement is essential to Dr. Palmi sir, whatever. I got a very good friend in the institution, our department. Thank you very much, sir, Dr. Palmi sir. Right. Please.
I am very happy to getting this chance to share in my thought with you in the wonderful occasion. Actually, the creation of mind have been taken for a very nominal persons. Up to our PG study, the learning process would be over, and after that, the creation will be taken in the part of research. Okay, here this program created by a single woman, I will not each and every activities, only the interest and is dedicated and met all the interruptions. He now successfully completed in this function because it is useful to a new subject. All the faculty members who are going to handling this semester, even the book is not coming in market, and also each and every topic will not having any book also. The important topics are already I was handling these topics. Number of books, even 12 books are searching in our library, and also even not downloaded from the website. Very difficult to collect the materials. I hope all the presentation will help, or at least given some support, some encouragement to you. We very thank, and also the program organized methodology we have learned through this program. We thank to the madam and pray to God in future lot of development program will be conducted through this department. Thank you very much.
Thank you, sir. Studying a paper in India, that is my first paper. Now I have presented more than 20 papers in international conference, but at that time, I saw madam. Everywhere, she is roaming, Professor roaming. He conducted a very big program in India University. This and all, குட்டி சும்மா எப்படி சொல்கிறது, அதை கம்பேர் பண்ணும்போது ரொம்ப சின்ன ப்ரோக்ராம். அவங்க 2010 பெரிய பெரிய ப்ரோக்ராம்லாம் பண்ணுவாங்க. நான் நேராக பார்த்தேன். ஆமாம், அதுதான் எனக்கு ஃபஸ்ட்டு. தட் இஸ் மை ஃபஸ்ட்டு கான்ஃபரன்ஸ் presenting international conference. Right. We know that proverb is there. திருவாசகத்துக்கு உருகாத ஒரு வாசகத்துக்கும் உருக மாட்டாங்க. ஒரு வாசகத்தை கேட்ட திருவாசகம் முடியும். தேங்க்யூ. ரொம்ப இந்த மாதிரி ஒரு ப்ரோக்ராம் கண்டக்ட் பண்ணுறது ரொம்ப ப்ரொஃபஸர் ரொம்ப நன்றி.
First year FDP program. I am so happy to attend this Sunday FDP program. It is very useful for me, not only for me. It is very useful for those who are attending the 7 days FDP program. I want to say only one thing. This is not only theory subject. I think translation, scaling, rotation, and mass probability calculation. These are some problematic in these portions. So be more concentration in that portion. So already we know theory subject that I have. So more concentration in that problematic portion. So thank you. Once again, thank you.
Thank Dr. Rajeshwari for conducting this program in successful manner. It's not an easy one. Okay, so because we are conducting so many programs in our college also, so even one day program also we are facing so many problems doing all work. So not at all easy one. Okay, so it's a very successful manner. So I want expect something deep in some of the topic in deep manner. So that's only I for example confirmations. They are saying only equations, not only the practical manner. It's difficult to explain it. That's another one. But I expect that. That's only that. Thank you for it.
First FPP program, and also this is my new subject based on my major ME production engineering. So I learned this subject. So based on the subjects and schedule, it's okay, sir. It's a new platform for myself. But I am unable to academic. I can't able to attend last few classes. I want to conduct this program on April, May. Useful for.
Thank you.
So at that time we get some vacation leaves. So easy to process for attending all sessions. So that's the only request to our students. Thank you.
And it is very useful to those who are taking CAD subjects, because in net also you can't download everything for the 4th unit and 5th unit. But this PowerPoint presentation will help us more to teach classes and to approach the students very well.
I feel very happy to attend this program. Really, it's very useful. ஒரே ஒரு டிஃபிகல்ட் தான் ஃபீல் பண்ணேன். இங்கே எது தெரியுதோ தெரியலையோ இங்கே வரும்போது நல்லா 8 கூட தெரிஞ்சிருக்கணும். அது ஒன்று தான் நான் டிஃபிகல்ட்டாக ஃபீல் பண்ணேன். மற்றபடி ஆல் அதர் திங்ஸ் ஆர் குட். Thank you.
Nothing less than the last year's program. It was conducted on DME, Mission Elements last time. The library month came. It was easily going through a cakewalk at that time. But we had so many difficulties this time. Like we had in one session constraints. That's why we learned the subject. But this is a good experience for us. We had nice sessions. Especially for those who are handling this subject newly, they will keep on handling this subject because you are the first generation of this faculty member who are going to take it as a theory subject. So you will be specializing in your college. You will have a good exposure, good value that you are handling this subject. And most importantly, you will be in a position to give notes personally to students. That's one good point about it, because students, they will rely on local notes or local other books. But this time they will have to listen your words. Students will certainly be attentive in your classes, and I hope this PowerPoint slides will be helpful for preparing your course notes. If you are not having anything like 2 marks or 16 marks, it may be contacted to our coordinator. It may be communicated via email, because we are leaving your contact IDs to us. So it is not a one-time relation, like you have come and gone. You can keep on contacting and clarifying your resources. And we are always helpful to we ourselves feel that we are not given full extent of the resources or whatever materials, as we say. This is also an experience for us, because they are shaping the syllabus. Most importantly, you have participated and given your feedbacks then and there. And the next speaker, he was ready to give according to your needs. We had multidisciplinary sessions, you can say, from IT department or from CS department or any other department. We have multi-college interactions. And I never saw a DP going in such a friendly manner like this. I gone to many FDP sessions, but we will always start with the methodology session, like how to teach and all. Being learners by practice, we need not be taught that way. That way, not wasting a session, just jump into the subject point of view and gone into the syllabus. Some faculty, they were interacting every session and asking for the clarifications. Some faculty members, they are not able to come because of the commitments they have got to the parent institutions. But at the end, everybody communicated well, and they were able to make this program very much successful. Thank everybody for kind.
Purushothaman, head of the Department of Mechanical Engineering, St. Peter's College of Engineering, and Dr. Jawahar, HOD, Department of Production Engineering of Veltech Engineering College, and Dr. Sandeep Kumar, HOD, Department of Mechanical Engineering of RFKCET. These people have sent the participants from my word. I requested them to send the participants, but I have to express my gratitude to them also.